Hello everyone, welcome to the second video covering examples from Chapter 9. In this video we're going to be looking at another ANOVA example. However, unlike the first one, this time we're looking at an analysis where the sample sizes are unequal. So the example is on screen here, but in summary we have randomly selected schools. The schools fall into one of three categories, either rural, suburban, or urban. And the researcher measured the mean age of completion of 8th grade for the three different categories. And for our analysis, we're going to see if there's a significant difference in mean age for those three different types of schools. And we're going to be analyzing at a 5% significance level. All right, so starting our analysis, we're going to start off again with that options function to make our output just a bit more user-friendly. And before we import our data, we're going to first create a value mapping, so then that way we can have better named categories just to be a bit more user-friendly using the proc format function. So this next line here creates something of a lookup table, so anything with the value of 1, for example, gets mapped to rural, and so on. So running this won't actually yield any output or anything like that. We'll just go and see the log, and since there's no errors, everything looks good. Looks like the mapping will be successful. So we can go ahead and start importing our data. And then as always, we use the data function to import data, and then use input to specify our variables, making sure that the $ indicates that it's a categorical variable. This line here allows us to use that mapping that we created above, and we're going to be formatting school to those values as described above. We use cards very similarly to data lines. It operates in much the same way. Then we can paste in our data. Here you can see that that left-hand column, our school variable, is coded with 1 through 3. That is why we use that proc format function, so then that way we can have a more descriptive name within that column. Then we can run this line of code to make sure that everything's importing correctly, making sure that that formatting function is working properly. So if we hit run, here you can see that that school variable, which was once coded 1 through 3, has now been mapped to the corresponding category. And because in this example we have uneven sample sizes, we cannot use the proc ANOVA, so instead we're going to use proc GLM. And then again, we're going to specify our dataset being used. We are going to denote our grouping variable using class, and then we're going to specify our model with age equals school. And then, not unlike last time, we're going to check for equality of variances using the Levin's test. Wrapping up the code here, we have our list of different comparison methods. These methods allow us to have a more granular analysis, allowing for one-on-one comparisons. These methods allow us to see which groups, if any, might be significantly different from the others. So our next step here is to actually run the ANOVA model and then do the final analysis for our data. So running the GLM function gives us this output here. So like the ANOVA function in the first video, that first section up on top just gives a description of our variable, and then the important stuff comes next. Again, we have those really important values like the mean square error and the R-square value, but this time we're going to jump right to the p-value. Here we have a p-value of 0.01, which is less than 0.05, so we have enough evidence to reject the null hypothesis. So our null hypothesis claimed that the mean age for the three different school systems was the same. However, we can reject the null hypothesis and conclude that at least one mean is significantly different than the others. Then scrolling down, continuing with the output, again we can see that we use the Levin's test to conclude that there is homogeneity within the data. And then scrolling down even further, we will be able to see the different comparison methodologies. So we start off with the Fisher method, which again is the most liberal. And then as you can see, denoted with the 3 stars are the significant results. So here, urban and rural, there's a significant difference, as well as urban and suburban. And then scrolling down, what the next we'll see is the Bonferroni method, Then here, only the urban and suburban are significant, and then that follows through with the Scheffe and the Tukey methodology as well. So depending on the methodology, there could be one significant comparison or two. So this concludes the analysis for this example. Be sure to watch video 3, where we run an analysis on repeated measures data. Thank you very much for watching.